now. Hi everyone, we are excited to restart our meetups after a while. As you can see, this is a virtual event, but we hope to start our in-person events soon. And of course, the mandatory introduction of the leaders of our amazing Delhi Java user group. Let me add the poster for our session today. So my name is Mala Gupta. I'm an author and I work as a developer advocate with JetBrains. Gurpreet?
Yeah, thank you, Mala, and welcome everybody for this event, and thank you for taking time out on this weekend. So I'm Gurpreet Sachdeva. I work in Capgemini, Gurgaon as Senior Director, and I'm passionate about Java and Java technologies just like you all. Vikas?
Hey everyone, I'm Vikas. I work for Cisco Technologies and I'm a technical leader there. I've been with this Java user group since 2012, and yeah, hope we will see you soon in a live event or in-person event. For now, let's go with the live event. And last but not the least, Steve, go ahead.
Hi everyone, good to have all of you here. I am Steve. I work as a software developer in Find. We are building a no-ops big data product. So if you want to see, you can go to Baltic.io. Apart from that, I've been associated with Delhi JUG since 2017. So we've been conducting offline meetups before COVID, and we are working hard on conducting offline meetups and regular online meetups as well. So that's it from my side. Before starting the event, I would also like to thank our outreach partners, Bangalore Java User Group, Hyderabad Java User Group, and Women Report. Thanks for all of your support. Back to you, Mala.
And before we start with the session, the main question, why this session? The world we live in is more connected than ever, and the applications we use, like online stores, navigation apps, social media, and so many others, communicate more with the servers and they generate more data events. But how do your servers handle this ever increasing load? What if one of the services is down? Would all be lost or would it require reprocessing? The businesses cannot risk this because that would mean losing money or opportunities. So the question is, how do you accomplish this? If you have same or similar questions, you are watching the right session. This session will try to address these concerns by using Spring Kafka, Kafka Streams, and Spring Actuator. Thanks, everyone. I will take all the co-leaders off the stream now, and then I will add our speaker to the stream. Yes, and hi, Co. It's a pleasure to have you present with us today. Thank you so much for accepting the invitation.
Yeah, no problem. Nice to be here. I hope everything is all going good because I have a little bit of lagging problem. I don't know. Yeah, let's see.
Ko, I'm so pleased to say that we don't have the lagging problem now. It's all gone. And thanks everyone who is watching, and thanks everyone for your patience because we had some technical glitch, but all is good now. So let me quickly introduce Ko. Ko has been coding using Java and Kotlin for quite a long time. He speaks at a lot of conferences, and he doesn't like PowerPoint presentations or the bullet points, so he likes to live code in the presentation. So all of us are in for a treat today. So, Ko, let me ask you a quick question. Have you been to Delhi earlier?
No, I never been there. I would love to visit one time India, but yeah, you know, family, work, conferences, and maybe.
Of course, you must visit. It's a beautiful city. And before I let Ko take the stage, let me share some quick housekeeping details for everyone who's watching. Please use the YouTube chat to post your questions. All the leaders from the Daily Jug will answer your questions. We'll try to answer your questions as you post them. And Ko will also keep an eye on the questions, and he'll post them as he presents the session. by taking quick breaks. And we are recording this session and we'll host it on our channel, the Daily Java User Group channel. So if you haven't already subscribed to our channel, you can do so now. And if you like the session, which I'm sure you will like, don't miss to like the video. Now let me add Ko's screen to the stream, and I'll let you take the stage now. Have fun, Ko.
Yeah, thank you very much for introducing me. Event streaming application with Kafka Streams, Spring Kafka, and Activator. That's our topic of today. Hi, my name is Ko Turk, and I'm a developer at Blue IT, now currently at the Rabobank. But more about something you will learn, like we are going to produce and consume some messages. And how? With some Spring Kafka magic. You will learn how to stream big data with the library Kafka Streams, and we will create some proper monitoring. So with the Spring Actuator library, I will all use Spring Boot, and I will be live coding. So yeah, everything could potentially go wrong. It happens in the past, but I will let you know how things work. So let's see. But yeah, what I said, it will contain some live coding, so everything could potentially go wrong. I will use IntelliJ as my preferred IDE. And yeah, we're off to go. But first, a small story. Imagine you are a developer in the 90s. You are one of the guys that need to create software that needs to communicate to other systems. What do? First, what you think about in the 90s, like you didn't have a Spring Boot, you didn't have REST, you didn't have SOAP, you didn't have or Corba, you didn't have what else we have more nowadays? Kafka. And yeah, so we had really nothing. So it was really a nightmare to talk from Linux to Windows. And yeah, you don't want it. And yeah, that's a pity that day, but they really wrote the whole socket themselves. And that was really hard that days because, yeah, Java was invented in 1995, I guess. So they didn't even have Java that day. But yeah, yeah, imagine that you need to communicate. It was really a problem. Yeah, it's on your own machine, it's okay. But yeah. But then, after some time, you had Corba. And Corba is now a haunted house. It's removed from GDK. But I want to say, like, you had something, a man in the middle that takes care of your messages and going to send to other machines, which you set up. And that was really an eye-opener on that day because, yeah, you have something and we can communicate with other systems. And you had a contract. It looks a little bit like SOAP. And it was not very handy because you have a lot of lag. You have something else like XML, not even XML, but yeah, that was really trouble. People on that day, it was nice, but still it was a little bit complex. And then when there was a solar eclipse in the Netherlands or in Europe, I was in France that day, I know that, and they invented SOAP on that day. And SOAP was really nice because you had XML, it's easy to understand, but still you have a contract in the middle. And if you want to change that contract, it's a little bit of hassle and you need to make all the objects from Java. And it takes some time if you want to make changes. So later on, they invented something new. It's called REST. It's developed by Roy Fielding, doing its PhD in the zeros. And that makes our life much easier because we can now communicate through HTTP. Like we can communicate through a get or a post or delete or a put or what else we have. So that was really nice. And you had JSON, and JSON is really easy. You don't have a contract anymore. Of course, you need to know the contract, but because you cannot send everything. So that was very nice. But nowadays, when we're talking about big data, you don't want to talk about HTTP. So you don't want to talk about synchronous processing of your messages. We want to process it asynchronously. So let's go asynchronously with Apache Kafka. And for that, I have some libraries I will introduce you later on. We will do some live coding, so please hang on. But first, event streaming applications. That's the topic of today. That was my little story. My name is Ko Turk. I'm working for the Rabobank. I'm living in the Netherlands, near Utrecht. So the Utrecht Jug we have there. I'm talking about Kafka, Kotlin, and Micrometer. Live in the Netherlands, like to buy it. And yeah, please follow me at Twitter. That will be amazing, or leave a tweet. But first, why do we need event streaming? You have three types of event streaming, or a type of communication I need to show. You have on time-based, like on a certain time something is happening. So a cron tab is run, and yeah, something is happening on the time. Like on the laptop, something is occurring, and you don't know what it is. That's like time-based. You also have something like the painting on the right. If you can look at it, but if you're done, it's done. You can go see it like going to the museum. If you're going to the museum, you watch some paintings or some statues, I don't know, and then you go into the next one, and then you're done. You're going to the next one, and maybe you want to revisit the other one, but you still need to do a call, and because you need to watch. That's more like a get. It's fire and forget. With events, it's more like a spider. If there's a spider crawling on your table, it can be one, but it can be two. It can be millions. What are you doing then? You need to handle it somehow, right? Like one you can handle, but a lot of those spiders, that's really creepy, right? So how to handle that? Yeah, for that we have some frameworks where Kafka could help, or some other frameworks, but I'm telling you everything about Kafka and Kafka Streams. So we want something fast to take that spider, because there are so many. We want something less complex. So we want to not grab it with our hands. We want to have something that grabs messages. We want something fault tolerant. We don't want to crash it. We want that it's if we have a lot of message, that it set up a new server somewhere so that it can process all the messages. Yeah, you maybe want to have the replayability. Like if you're working at a bank, for example, you want to know, hey, if a message is lost somehow, you don't want it like a payment. So if something is going wrong because you have a null pointer exception, I don't know, it could be anything, I hope not. But yeah, you don't want it, right? So yeah, you want, if it's crashed, okay, it's crashed, you fix your issue and then start again. And then you want to process that message again. So you don't want to get messages lost. So that's a nice thing, feature of Kafka, I think. And yeah, for that we have Kafka. I get a lot of questions from people, why not using RabbitMQ? RabbitMQ is like, it's more like fire and forget. And Kafka, you have possibilities like saving the messages to a disk. It's not mandatory. You have a kind of retention time. So you can say, hey, forever I want to save this message. It will take some disk because Kafka is saving everything on disk. Yeah, you have that replayability possibility. Of course, it can also be going with RabbitMQ, but that's mostly very complex and you don't want that. So yeah, there are a few things which I like about Kafka. And one of that is Kafka is batching everything. So if you are running a Kafka or a Kafka cluster or somewhere else in the cloud, it's even better, I guess. Kafka is batching all the network calls together, so you have less lag there. We have a kind of if you're looking to remote, you need to search everyone, and it can take a time. But within Kafka, it don't need to search, it's only adding things. So it has an own remote, and it's only adding messages to the log. It's a kind of data structure within the computer or the server. And yeah, you have less copy actions within Kafka. So that's why people telling on the internet, and also did a little bit research, that Kafka is quicker. Kafka is writing to disk, but that doesn't say it's less quick. Like you have, of course, you have in memory, but Kafka is quick because it's also operated on a different level, on even TCP/IP level, not HTTP or something. But yeah, you have 3 flavors, and we're also going to a live code. So have a few minutes. It's almost time. We have something like Kafka Connect. And with Kafka Connect, you can connect data sources with Kafka, and you can put it like on a topic. And you can, if you want, save it or sync it to another database. So for example, you have a GBC connection to an Oracle database, and you want to transfer everything to a MongoDB database or Elasticsearch. You will hear a lot. So that's all possible. Mostly Elasticsearch is used with this kind of action because you want a kind of business intelligence. So that's really useful. I'm not talking about this one. This is another topic. I will tell everything about this one. We will create a REST service, or I already created, because I want to show you everything about Kafka. So we will do a call to a Spring Boot application, which runs Spring Kafka and the activator. That's the first thing. And we are going to produce something to a topic on Kafka on a different server. What I said, it can be a cloud, or it can be anything what you want. And it's all possible there. And what we also want is we want to consume it. So we want to consume that message. So yeah, so we have produced the message and we will consume it. And I will show you how simple it is to use that API of Spring Kafka. The next step is some big data. Yeah, with big data, I mean like you have a server somewhere, it can connect to your Kafka topic and you can send something to it. Or you have somewhere REST servers on the internet which you can do a payment and it's producing to a topic. You can do all kind of things. You can send it to a topic and then we pick it up as a streaming application. So we send a lot of data to this one topic, and this topic you can have millions of data, billions. Kafka can do it for you, and that cluster is doing it for you, I need to say. So yeah, we have a streaming application. We will create a Spring Boot application with Kafka Streams, with Actuator, and with that said, yeah, we are going to join an application. What we will make, we will create a banking application where we get a payment of a topic. And we want to do a payment to another account. And for that, you also need balance. So that's why you see a join here. We want to join the account, the payment, with the balance. Like, is it possible to do the transfer? Because does he have enough money? So we need to join there. There are all kind of joins, by the way, but we are using the one join. And later on, if that join succeeds, we are writing it to another topic where we can check on frauds. And if we have a fraud, then we can do something like checking the IBANs. Maybe it's coming from an IBAN that's not correct. In Europe, we use IBANs. I don't know what you in India are using, but yeah, that's a kind of account structure. And yeah, if we have some fraud, we can put it on a topic if you want. So a lot, but I will show you simply how you can do it. So let's see. I'm also wondering about you. Like, yeah, if you want to go to menti.com and use this code, it will be amazing. I have some questions for you there. also going to Menti because my computer crashed. Sorry about that. But we handle it now quite correctly, so that's nice. So I will also start it if it's not started yet. So please give me a second. So it's already, people are already voting, so thank you for that. Are there more people voting? That would be really nice. Thank you. I'll wait 1 minute, then people can vote. Perfectly, I see people are voting. Thank you. Okay. So I've here the results. I hope you're still there. And if you have questions, please let me know. So that will be nice. Mala? I don't think so yet, right? No. I see we use the have offline meetups to. Oh, that's some more question for the host. So what you see here is what I already expected. People are using REST nowadays because it's really useful. And I forget to put GraphQL. It's also a nice one. I didn't put. Oh yeah, I put it in to even use it. So that's also something to get your attention to. But if you have really a lot of data, you want to use something with Kafka. So perfect that people are using Kafka, the consumer and the producer, but the StreamsAPI not. So I will tell you everything about the StreamsAPI. So that's quite good, by the way. I'm happy because I'm going to tell you everything about StreamsAPI. So what you need to know. So thank you for that. I have another question. I don't know if it's still there. It's not opened, I guess. If you go to the next one. Can I go to the next one? I can do this. So I'm just curious where you want to learn about. I think, I already know the answer a little bit. Yeah, cool. Yeah, somewhere, I think the heavy point is on Kafka Streams, so I will check the voting later on also. So thank you for voting. Going the other way. So thank you for that. So now it's time to eat some code. I'm having my IDE here on the other screen. So I will do it here. So, okay. So I will change it. Sorry about that. So what? Yeah. So I first show you the Project Explorer, and later on I will show you everything about the code. I have two modules. One basic, where we tell everything about the basic Kafka, and a streaming module, where I tell you everything about the streams. So the StreamsAPI or the Kafka Streams. And we have a common, where I have some Docker and some images. So in the images you can see something like there are 3 flavors. So what I said, we are first going to do this. We have a simple REST application which we are going to send a message and consume from. So this is our first step. So I will go to my project structure. So we have a configuration, a controller, exception, something with Kafka. So mostly you are beginning with application and then going to the controller if you do a REST call. So I will close it. So now you can see everything about code. So we have a payment controller where we have a post mapping. Normally you have also a get mapping and a delete mapping, but we only do the post now. And we are going to process a payment and we're going to send that to Kafka. So Kafka is really amazing about that because you can produce something to a topic, and we call it a payment producer. And the simplicity is here. The only thing you need to do is 2 lines of code, and I'll show you now. I have some live templating of IntelliJ. It really helps me a lot because, oh, it's already there. I didn't put it away. So the only thing you need to have is the Kafka template. And within Kafka template, you can say, hey, I have an account and a payment. But where is that account or payment coming from? This is an Avro message we call, or it's generated by an Avro plugin. Within your POM, you can say, hey, I want to generate some things like Avro objects from Avro messages. And it's coming from the POM. So you can, I will send you the link later on of my GitHub. It's all there. It's already there. So you can already look if you want, but not all the code is there. So I will commit it later on when we live code it. So we have a payment object. So in Avro, it's a kind of XML. You can say you have a namespace, a type, and your fields. Like I have a name and an IBAN and a to IBAN. So that's how it works in Europe, and an amount and a balance. And that balance is not there yet. We are going to save it into this message later on. So that's why it's balanced in there, and if it's processed. So with that, you also need an account, so because you need to know, hey, where is it coming from? Like, is it coming from the right people? You have a name and an IBAN and a balance. And that balance is just something like this. Like I said, this is live templates from IntelliJ. I really love it to use it within my presentations because, yeah, I'm not coding so quickly, so this is perfect. Thank you. So, yeah, it's a float, an amount, and we have a currency, like the balance. So yeah, you can think about all kind of fields if you want, but that is our that are our objects. And back to the producer. So it was in the producer. I have a producer here. So I will again do this again. So we are going to process the payment, and the only thing we use is Kafka template. So it's sending a transaction, and the transaction is here. So the only thing we need to do is 2.4 is send the message. Kafka template.send the topics. You don't even have to send a key if you want, but yeah, we are joining the balance, so we need a key and a payment. So this is all the things you need to know. Easy, right? And yeah, you can always have an exception. It can happen that you have an exception somewhere, like in your code, you're doing something and it's crashing. For that, we have some Spring actuator. And it's the metric, like I have an exception, I have a payment. If it's this IBAN, it's an evil IBAN or something, it's doing something evil, then you can have a filter exception. It's just an exception with some name, and you can say here is new filter exception. And oh no, help me, Mala. Sorry. And or someone else, or help me. Oh no, help me. So we have a filter exception with up. So we have a counter.builder of Spring Actuator. I can also show you later on the libraries. We are using Spring Boot Actuator, and we use it within my Maven build or your Gradle build, what you want. And we create a counter, and it has an exception. So a.message.exception. So that's the name. We have a tag with exception, and we can do something like get the message, and we are going to increment it. So this is the first time we created a counter with a 1 in it if it's occurring, and then with the message. Oh no, help me. And then here I want to throw it somehow. So we are throwing up. And I like that joke, sorry. I miss the audience like this if I'm making this kind of jokes, but nevertheless, sorry. Yeah, so we have our first exception here, and otherwise it will send it. So we are producing a message here. So yeah, you can forget this, right? If you are only interested in Kafka, it's just Kafka template.send. So we also have something like a producer or a sender, sorry. We're going back and we have a consumer. And that consumer, the only thing you need to know is again, two things. This one is you have a Kafka listener. It's also from Spring Kafka. You need to define the topics. Maybe you have some multiple topics. I don't know. You have group ID, like something. And the only thing you need to do is public void consume. And it reminds me about some music, but but nevertheless, I will spare you. 3.2, and you want to cast it to the payment. So what I do here, I'm getting the consumer record. It can be anything, or yeah, or normally you say, hey, I have an account or a payment, but I'm doing multiple things with it. So that's why it's a question mark. Don't use it. Make it specific. Yeah, we have it like here, consumer record.value. So that's the only thing it uses. So that's pretty nice, right? So, and we save it to our own class. So I'm going to start the application and show you some things. So I'm going to start it with an IntelliJ. You have a kind, let's debug it. And let's wait. Oh, sorry about that. Enable it, sure. Services, it's loading. Like I said, my system is a little bit lagging. There it is. It's connected. And we wait for it. We have even started Docker. Possibly not. No. Let's start it. In what I said, within, yeah, it's now complaining because it doesn't find a connection because I need to start Docker. And it also reminds me that I tell you something about this, like within common. If you go down, I have a common with Docker, and I have a Docker Compose here. And within the Docker Compose, you have some, you can just run it. And what it does is just, if you do in Docker Compose, it's a start script here. So you only need to run the start script. It's running a zookeeper. So within Kafka, you need something that listens to all the servers and check if it's alive or not. So you need zookeeper for it. They have something new. They want to get rid of it somehow, and they have their own. So you don't need a different one. You can also use Kafka. So this is all the logic or the clustering and that kind of thing. So Kafka have their own. I'm using that one of the vendor Confluent. I really like that because they also have many tutorials on the site, like developer confluent.io. It's also nice. So go there if you want to read more, like you want to know something about error handling, or you can find it there. It's really amazing. It helped me a lot when I was beginning with Kafka a long time ago. Yeah, and we need to say zookeeper, that kind of things. You can have a Kafka topics generator that you generate a topic like payments, fraud, rewards. I don't do that right now. I will do it in a code. That's nice, right? And we have a schema registry where we register all the AFO message. Like you need to have somewhere, you need to have a registry where you say, hey, I have an account and it's a version 1 and I have a value of that and that's a payment. So that's a topic, those two, that combination. So yeah, also you have schema registry from Confluent there. You can use, it's free. Only if you want to need more replicas or instances like that. So if you want to have more, then it's paid somehow. And I have a UI to show you how to deal with Kafka. So it's a kind of Confluent also have a version, but I'm using the Kafka UI version. But yeah, that's how I made it earlier. So I created something. So I'm again going to start it. My Docker instance is running. Hooray! And if there are some questions, please let me know, Mala. Can you give just an okay or somehow? Then I know you're still there.
Heiko, Vikas has been answering questions, so I think you can move on with your presentation, and we'll have some questions for you towards the end of the session.
Yeah, sure. Yeah, let me know if I have some. Yeah, okay.
Okay.
So we continue. So I started it now, and you can see, hey, it's the petitions are assigned, and I have a topic called payments 0. So we now have our payments topic. So that's really cool. By the way, I didn't show you this, and it's really cool, I think. You can also create from the code, you can create your topics instead of doing some things in Docker Compose or in a Docker file. So you can also use something like the topic builder. And the topic builder is also coming from Spring. So that's really useful if you want to create or you want to know sure if your topic is there. Like if your topic is not there, you want to create it, and it's creating with so much petitions, replica. And if it's needed to delete it, your topic, or maybe you want to have 1 week that it needs to be saved on your topic. Maybe you need to get rid of it right away. So that's all possible. So somehow with the compact. And we create a payments topic, we are creating a fraud topic, we create a blacklist topic. So that's all possible. So that's pretty cool. So I'm starting it, and I think I'm just doing this quickly. Within IntelliJ, you have the possibility to create an HTTP request. So you can just do HTTP. You can just do it like this, HTTP request, and you can create your HTTP request instead of doing your things with Postman. I'm liking this, so we will do something like this. So on this moment, I send some messages to a topic, and it's created a payment. It's all good, and it's saying, hey, 200. So I'm going to my Chrome browser, and we have a Kafka UI somewhere. Is it running? Yeah. So Kafka UI. So I have my Kafka UI. This is just my schema registry util to show it. And here you have a payment. I already sent some payments because I already testing with it. So I have 6 messages now in the payments. And I already have some messages in the other topics. So that is more about Kafka. That is all about Kafka produce and consumer. And now let's deep dive into the StreamsAPI. So within the StreamsAPI, you create a topology. You have a payment topology. You can handle streams with it. So what I show you, like within the images, you can have a streaming app. So we have 2 streams within one Spring Boot application. Is this possible? Yeah. So we have a payment stream. It can be also within different departments if we want. And we have a fraud stream. It can be also another department. We just put it in one. So we have a payment stream. Because of the time, I'm going through to it. So what we are going to create is a stream of payments. Let's move it like this. So we have a payment stream. The only thing you need to have is a case stream with an account and a payment. You build it with the builder you get. If you want to search it later on, it's all my GitHub. So don't be mad if it's going too fast somehow. It's all on my GitHub. And I will commit it later on after this. Or you can go to another conference where I already did. We are going to create a K table. So we want to join the payment and the balance with each other. What you can do is something like this. You can pick it if you want. 4.2, we pick it. So what you can do, you can create your metrics within it if you want. I will show it later on because I want to show you some more about the Kafka Streams. But yeah, we are creating a counter here, and if you go to this URL, then it's giving you all payments with this bank code. It's really useful if you want to measure things or you want to monitor things in your dashboard. So it's not only logging, also use create metrics, especially in a big data environment. You should do it. Like don't do something like system out print line, even don't do it, but don't do it all log debug, don't do it, only create metrics. It's the only point I will want to make it. We also have 4.9, of course 4.9, and we are going to join. And we join the balances and we enrich the data in this message. So we have a balance and I'm going to add this in the balance. I don't show it right away because that makes it complex. It's adding the balance to our payment object, what I've shown you. You can filter within Kafka Streams. You can filter. It's just like a little bit like StreamsAPI. It's having the same possibilities or the same methods you can use there. So you can also use it in the StreamsAPI. And it's really useful and easy. So you can filter. You can say, hey, the balance needs to be bigger than the amount. That's easy, right? And then we are going to map it to our own. Oh, sorry. We are going to map to our own value, like a fraud object. So we have a payment, and we want to enrich it in a new fraud object. And we want, you can peek it again, and we can just also send it to a topic. Peek is more like if you want to print something or create a metric. That's only useful for peek. Leave it out here because I already did it there. So yeah, log as much as possible if you need it, like, or do a debug so you can debug it later on if you have a problem. So if something is having an exception, you can trace the whole route. So in this moment, we created the first stream. So congratulations. And we need to return it, otherwise we don't have it. So in this moment, we create our stream. Going back, I'm going to start it. But first, I want to stop the other service because it's not used anymore. So what we are going to do is start the application. I have an application here, and I also added something more, and that is really cool. I have a website here where you can visualize your whole Kafka streams. So that's really useful if you're new to Kafka and you made something, or someone else is new to Kafka. You can visualize it, and that is really a nice project of CZ85. I don't know who that is, but thank you for that. And yeah, you only need to print a topology, and we are going to copy it from the console later on. So I'm going to start it, and I'm going to debug it. We need some seconds. So we are starting, and I'm going already to that website. Where is it there? So this is a visualizer, really useful. It helped me a lot with complex situations where you not exactly know what happens. And here we have, it's already processing. So we already put some message in it. So it's already enhancing the message. So we're already in a join, and we created some balance already. So yeah, it's checking balance there. And the next step is enhance it. So what I show you, we are saving the balance amount into this message, and we're going on. And it's there. So oh, we didn't have a peak here. So I I'm missing the peak here. Otherwise, you see here, it's processed to fraud. So in my fraud object, you now see an extra message where it was first, it was like, it was a 4, but now it's like 5. Should be. Oh. It's now 5 here. So that's, we sent a message to the fraud topic. What I show you, you see here all kind of things that were really useful. I will show it with our application, what we already built. I hope we have some extra time, Mala, but yeah, I be as quickly as possible. Topology description. So I have logged this one, and you copy this phrase to this one, and we can visualize it here. So I'm going to put it here, and hey, there we have created our first stream. So we have a payments topic and a balance topic. They have to set the other source, right? And they are, this one is speaking it, like creating a metric, logging. And here is taking a new state store. So we have created a store here with balances. So the next time, if we want to join, we know already if it's into it. So we are much quicker there. We do a join, we do a filter, we do a map, and we sync it to the fraud object or the topic. So next step is to create a fraud stream. So I'm closing all the things again. So we are going to create a fraud application. So on this moment, we have a case stream. Again, we want to pick it, what I said. And maybe you have a null point exception there. And I will tell you something more about it later. And we want to filter it. We want to filter this IBAN. I have some try catch here, but the only thing it's doing, it's filtering or throwing an exception. You can always you need always to catch your own exceptions within a try catch, so you can handle them, right? If you expect something, you need to handle it. But if you have a null point exception or something, then you need to catch them somewhere else or try to resolve them. More about it later. We can map it, map the value to a new fraud object and payments, and we have a new object again. You can pick it like what I said. If it's too fast, sorry about it, but that's because of the time. You can log it. We got a fraud here, so we all here like, hey, we are first thing is pick it, print it, filter it, map it. Again, log it, and we have a split. And a split is really interesting. So like if you want to split, like in blackjack, you can split. It's a game. If you have the same card, then you can split it. Like you have a 7 and a 7, you can say, hey, split it. And you have 2 pairs or 2 branches. You need to say that you have a branch. And it's giving back a true or false. So this can be also like this, a true. Or like here, I think here. Like this is giving back a true. So you can also do it like that, but you have a method where you do analytics. And then you can say, hey, send it to the rewards if it's true. In this case, it's false, always false. So I have it here, well, let's do it like this. We have a false. And you can have a default branch. So in our case, it will be sent to this one. Oh, not split. 5.8 to the default branch. So the default branch is now, it will always send it to the blacklist because it's the default and this one is false. So we created our second stream. Wow! Nice. I'm really enjoying it here in my house. So we are returning the stream again. And we are going to send it again. So we created this, you don't need to check, but in this case, we are creating another stream. So we're going to restart our service. I don't need this one, so we do a restart. And again, it will log the topology. So I show you what we made to make it even less complex. We'll just do it like this. So our Spring Boot application is starting. Should be. Oh, there it was. I hope it's still there for some time. So we have our topology. So if I now add this one, it's having like two. Like this we already made earlier, but now we added something new. And that's this one. So what we did now, we're reading from the fraud topic, like a source. We log it or throw something. Filter it, like it needs to filter on a kind of IBAN or somehow. We map it again to an object because we want to have another object. We again log it and we split it here. And this is very interesting. Like we're branching it here. This is split. So one is going to the blacklist. That's the default branch. And this is the other one. Like if it's true, it's going to this one. But in our case, we made it always false. So it's always going to the default. So yeah, you can make as much of splits if you want, but yeah, think about performance, right? But yeah, it's not so. It's very quick. So yeah. So we make our second application, and I already have some things like here. Of course, I also added some tests here. It's an embedded test where you can test some things like, hey, is it sending to our message, but our topic, but we already did it. So I can send it again somehow. Yeah, let's do it. Let's check if it's run. And check our services. Oh, I hope it's there. Oh. So, oh, it's already checking a fraud and it's already got a fraud early on. So, and it's doing a new test here. I created a test. You can also find it on my GitHub. Google to GitHub Code Turk, or just I will leave the link later on. So, yeah, please hold on. We're almost there. If we need to be on time, let me know. So this is really interesting also. I again created a new message and you can see, hey, it's checking the balance and it's proceeding, it's checking the fraud. And he says, hey, I got a fraud, don't process it. And it's going to send it to another topic called blacklist. I don't reload because it's very slow on my machine, but you have a blacklist here and you have probably now 6 messages here. So that's pretty cool. And you don't have anything in the rewards because we set it on false. So that's really, really handy. And what is also handy is the last thing I want to mention before stopping live coding. That is this. You don't need a whole Kafka cluster to test. You can also just test it in memory. I'm going to stop my this ones because to show you that's also working here. So I have here, it's a lot of boilerplate, sorry about that. You can find it on my GitHub, but the only thing what we want to do is we want to send something, pipe input, a new account, or 2 accounts even, and with a payment. So we have a balance, we put something on the balance topic and something on the payment topic. And that you can do it with the Spring Boot test, so it's all in memory. So it's a kind of bytecoding it. So it's not setting up a cluster, but it's within bytecode, it's doing a more or less a little bit the same. So what you can do is like this, run it and build it. It's building. Yeah, and it's testing. So it's now doing the stuff within my own machine. And yeah, you don't need to set up a cluster to only test or create a JUnit test. So that's really nice. So if you don't want to test it, like I tested, like it was more a regression test what I did. And this is more like a JUnit test. So you can do it within your build itself and you can do as a separate step in your pipeline, you can do a regression test where I show you the embedded test. So that's the most important stuff. One more, like a dessert, cherry on the pie, is the exception handler. You also have exception handlers, 3 types. You have an uncaught, a custom production. If you, within Kafka, you can deserialize something, you have an exception handler for that. And you have a serialize within your application. So if you want to send something to Kafka, you need to serialize it. And when you get it out of Kafka, you need to deserialize it. So some things can happening and you can recover from that. And that you can do in those handlers. Please look it up later on in my GitHub. It's very interesting. You can say you can resolve for an exception. Like if a deserialization exception occurs, you can say, just go on. That's really cool. And mostly uncaught is, you need null pointer exceptions you could not fix because you need to fix it in your code. But that's or in your data. But that's something else. So that's the most things I want to say to you. So what did you learn today? We created a consumer with Kafka Listener. You can forget everything, but remind this, consumer, Kafka Listener. Producer, Kafka template. Kafka template.send. And with Kafka Listener, consuming is just create a method and do something with it. Easy, right? And with Streams, we have a StreamsAPI with the Streams builder. So think about it as the StreamsAPI of Java. I can do my filter, join, I can do mapping, I can do flat maps, all kind of things if you want. The Streams builder. And don't forget to use the actuator, create your metrics, because it's very helpful if you have an issue, because you know where to look. And it saves you a lot of time, and your product owner will not be mad at you. So for more fun, you can see these references. For Spring Kafka, you can go to spring.io. With Kafka Streams, you can go to developerconfluent.io. It's really helpful. It's giving a lot of tutorials. You can go to Spring Boot Starter. It's a YouTube video. And it's tell you everything about creating metrics, because I was very quick with it, but it's a topic on you can also follow. So that's the most I want to share. I want to thank you. The slides as promised are here. I will commit it in half an hour or something, and you can copy this QR code or check this link, Google it or somehow. And I don't hope you have bad nightmares from this, because it's really easy. I want to show you the simplicity of Kafka. Thank you very much. Please follow me on Twitter. And back to you, Mala. And back to the questions, I guess, right?
Okay. I have to unmute myself. Yes. Thank you so much, Ko. It was an amazing presentation, as usual.
Thank you.
And I want to thank everyone who was watching patiently, listening, and they posted their questions. So, Steve, on to you for asking the questions.
Yeah, sure.
I'm going to go for the first one, I guess.
Sure.
It is from Alejandro Martinez, and he wanted to know which theme you are using for IntelliJ.
Nice. Yeah, in IntelliJ, you have a lot of themes. Mala can tell you everything about it, I guess, but I'm using the material theme UI. It got some free templates. It's material theme. I always got that question. I deleted that slide, but I think I need to edit again. But I'm using material theme, and yeah, it gives me some better view on things. Like I like some colors more, and I like it. I'm using it already for a couple of years. So yeah, material theme.
Yeah, thank you. Steve, you want to ask next one?
Okay, sorry. I also need to unmute myself.
No problem.
Okay, so yeah, Sarun asks, with what data volume should we start thinking about using Kafka?
Oh, thanks. With what data volume should we start thinking about using Kafka? Kafka is saving its messages to a cluster, so it's saving it to disk. So it's not in memory, like you have all kind of things like Hazelcast is doing all kinds of things in memory. And with Kafka, Kafka is writing it on disk, and it's doing that very well and quick. And yeah, I also want to say something more. Like Kafka is really nice. The DSL is really awesome. Use it wisely. Like if you don't make it, don't make it complex, right? So the Streams DSL is very useful, but use it like situations where you have big data. Don't use it only for your REST service or somehow, but if you have a lot of data, it's really useful and it's very quick, and you can do things asynchronously in separate applications. So useful, but use it wisely. But I hope you answer your question, Tarun, about the data volume. It's just disk.
Yeah, I think he was trying to ask like how big my application should be when I start thinking about using Kafka, but I think you have already answered that it can be used even for
Yeah,
small use.
you can imagine if you have a lot of data, it's very useful if you use big data, if you have a lot of transactions every second or every minute. Don't use it when you only use batching, then use Kafka Connect maybe or somehow to save it to an Elasticsearch database or somehow that you can use. But yeah.
All right, thank you. Next question is again from Alejandro. We want to ask what happens when you define a topic in your code and with this builder and the topic already exists. Is it modified or it does nothing?
It does nothing. Spring is clever enough to see, hey, this is already created, and what I shown you with the topic configuration, yeah, it's building it, and if it's not there, it's doing nothing. So it's more, yeah, it's really nice if you know for sure if topics are not there, then you know for sure that they are there. But mostly you are using something like a Confluent or an actual vendors where you can create the topics in a GUI. So mostly you're doing like, I create a GUI and this application needs to read from that application, and you need approval for that because that kind of things like authorization, I didn't mention it, but it's also a topic. But yeah, you can imagine there, you cannot create it from your code, but you need to go to a GUI to authorize and to read some things. So yeah. So yeah, it's handy if you have your own cluster or for demo purposes, but mostly if you use a Kafka in production, you use something like a schema registry where you define all your messages, Afro messages,
Yeah.
and authorization. Yeah. Sorry about that, too much, but yeah.
Okay. Next question is from myself. I want to ask you that you have covered why and how to use Kafka Streams in this presentation. Can you share when not to use it?
Yeah, I already said it a little bit. I think if you're not using something with big data, that's maybe a slide for the next time. Don't use it for if you have only a REST service and you want to save something somewhere, like you have a kind of process that's saving a message to a topic, and it's a little bit like doing what a database does. For that, you have other options like MongoDB, I don't know, or that kind of things. But use it wisely. If you have big data, you are like payments, transactions. Yeah, you can imagine there be a lot of it, and it's big data. And for that kind of situation, use it. Like if you have a lot of messages per second or maybe minute. I don't know where that line is, but yeah, think about it yourself. Like, yeah, use it wisely and don't use it for everything. The Streams API is awesome, I know, but if you have messaging, you have also other streaming possibilities, right? Yeah, their own with their strengths and weaknesses. So use Kafka when you go big data, I would say. But that's my personal opinion, maybe. Yeah.
All right, thank you. The next question is again from Alejandro. He's our star today. What happens if you block the listener with a long operation? I guess it will not consume anything more meanwhile.
With a normal consumer producer, you could have these problems indeed. You can also go reactive, and you can also go reactive with Kafka. But for that, you also need to be reactive on your application. Like people are thinking, hey, Kafka is reactive, it's not blocking. Yes, it could block what you said, yes, and then it waits in a long time. So you need also think about in your application, what happens if there's a blocking operation. Like I'm using, for example, also Kotlin, and within Kotlin you have possibilities with reactive. It's using some library, I don't know anymore, but you can use Ktor somehow. And think about in your own solution, like in your application, if it's blocking, what are you doing? And reactive, it's meaning like it's not blocking. So I would say read more about reactive and how you create reactive application. Kotlin is a nice example with coroutines, or you now have Project Loom with Java, but is it already in Java 18, 19 somehow? But yeah, Project Loom is also coming, or it's already there. So you can also look there for Java, but I would say, I'm using Kotlin, I'm using coroutines. So read more about it. It's again another topic. So you should be reactive in your code, and don't call databases and such thing. Use Kafka Connect for that kind of things. Don't do it even. Don't call REST endpoints and that kind of things. Think wisely, or think it in your application to make it more resilient. So it's not something about Kafka, it's about your application, I guess.
Really.
Reactive.
So next
Nice.
we have is, can we do some kind of rate limiting with Kafka Streams?
What kind of?
Rate limiting. So some kind of rate limiting do we have with Kafka Streams?
Read limiting. Why do you want to have a read limit?
For whatever reason, let's say we want to stream data and we have different plans. For a particular plan, we need to process data slowly for whatever reason.
Read limits. I have no idea. I think you should create it in your own application. Like if you don't want to read something, it's more sounding like a business logics requirement. So build it in your own application, I would say. Like I show you, we have a split. So if you you can also create a counter, and from there, if it's like if the counter reads the limit, you can stop reading, or you can produce to another topic. Or it's more like a business requirement, it sounds. And I don't know if it's possible in Kafka, but it sounds to me like more a business requirement, and you should handle that in your application. But that's
Okay, thank you. One more question. It is related to SSL authentication. Does Kafka Streams support SSL authentication?
I'm thinking. You have, of course, your key stores. Yeah, it's supporting, yes. And of course, otherwise we're not using it. And there was also something, coming, but more on that later, I guess. But I would say, you can use you can use key stores, and you can handle that somewhere in a configuration. Yes, I didn't show it, but somewhere in your YAML you can set it up, or you can set it up within your application. But that's maybe a nice addition for next time. Yeah. Thank you. You can do it. Yes. of course.
Yeah, one last question.
Yeah.
It is related to like this session. We learned like the demo application, but any like knowledge you want to share from the production environments you learned over the time, what not to do with the Kafka Streams. You already covered that topic, but yeah, any other learnings we should use from the production environment.
Yeah, I think I already said it, right? Yeah, with streams, don't make it complex, I would say. Just like the Java Streams API, you can also do a join, filter. I don't know join, by the way, but filter. You can flat map. You can filter again. You can just combine two streams with each other, and that's really complex. Don't make it over complex. Like, think about what you are creating, because the next one is also going to maintain it. So yeah, that can be a downside. Yeah, but that's also for the developer, I think. Don't make it too complex, because yeah, it needs to be easy, right? If you have doing too much things, maybe you need to think about separation. Maybe you need to think about separate it to another application, because you can create another Spring Boot application, or maybe another module within your repository, and you can create there. So keep it easy, keep it less complex. That's the most important thing.
Thank you. Mala, over to you.
Yeah, nice.
So Gurpreet is Gurpreet, your turn now.
Yeah, no. So just wanted to thank Ko. It was very insightful. I learned a lot. In fact, I myself learned a lot, and I'm sure all the participants in today's meetup have taken some useful nuggets, and they can enjoy, going forward, experimenting and programming with streams. Quite insightful. Thank you so much, Ko, for joining our session today, and hopefully we'll be hosting physical meetups maybe in future, just like we used to do before the pandemic. And I'm sure that we'll meet our Delhi Jug participants sometime in near future in physical mode. Thank you so much, everybody.
Thank you. Thank you for having me. I enjoyed. Thank you.
Thank you, everyone.
Bye.
Thanks, everyone. And don't miss to follow us on the social media, and of course, Ko, to know more about the topic that he talked about today. And as Gurpreet said, we hope to see each other soon in person. Thanks again, Ko. It was a pleasure to watch the session. Learned a lot again. Thank you so much.
Yeah.
Thank you.
Thank you.
Bye.
Bye, everyone.
Bye-bye.
Bye.
Right.